Good. The title is JSON and Soda with the Oracle Autonomous JSON Database. And what's today's agenda? Well, we're going to go through a workshop here, but before we do this, and to give you some time now to sign up and to provision a database, I will speak a little bit about developing applications with JSONs. So with half an ear, you listen to me, and with the rest, you sign up and provision a cloud databases. So this is the second link to the lab that also explains how you get your autonomous JSON database provisioned. Good. And let's start on a use case. And we want to compare developing with JSON versus using the regular, or not regular, but conventional tabular relational approach. So let's say during the COVID time, we had a bit of time, we didn't have to commute to work, so we all got a few little time back, and we decided to create an online store to sell some of our goods. And we said, well, we don't want to over-engineer it, we just see if this sticks, if this makes sense. And we say, oh, let's sell our used books and maybe the movies we're no longer watching. And if this is a good idea, maybe we're selling more things in the future that we don't know yet of. And we realize that there are some attributes that are true for every item that we are selling, like a title and what it is it a movie or a book? Then these things have a price, and because they're used, we may add a condition and a description. So these are all shared attributes that are true for everything we're selling, but then dependent on the product type, we have additional attributes. Like a movie has a list of actors, and you can change the language. So we have a list of languages of these movies and the format. Is it a DVD or a Blu-ray? And for a book, for example, there's one author, and a book you typically can't change the language. So there's only one language here. And we go ahead and we pick one programming language here. I just used Java, and it's quite easy. I create a superclass, an abstract class product that has all the properties that every product have that I'm selling. And then I use type inheritance to create a subclass book, which has the author and the language. And there is another subclass movie, which has the format and a list of actors and a list of languages. So this was quite straightforward, didn't take a lot of time. If I'm starting to sell more products in the futures, I don't know, stuffed animals, posters, etc., then I would just use type inheritance and extend another class from product. But now it's not only about transient data, it's also about storing this persistently. And what this means is, on the left side, I'm now comparing the relational approach, where you start out normalizing your data. So you realize you have some entities. These entities have properties, and then you may start with ER diagrams. And at the end, you have a bunch of tables. These are 7 in this case. And these tables are somewhat connected. So for example, movies and actors, there is a mapping table in between, because these two entities have an N to M or a many-to-many relationship. A movie, all the fun movies I know have more than one actor, and many actors are successful, so they get a chance to play in another movie. So it's really a many-to-many relationship. And this is how we end up with these various tables. And before I can even insert my first product, I have to create tables that back this up. And for this, I need to list what are the tables, what are the columns, what are the data types of these columns, what are foreign key, primary key. So this is basically conventional schema design. And once I've done this, I can insert my data. Well, on the JSON side, as we're going to see, the mental model is different. We're not working with tables that are backing up our business object. Instead, we have something called collections, and collections store JSON documents. So you can think of a collection just as a bag, which has a name, and in that bag, you throw in every JSON you want. And here we just call this collection product. So no schema design, just a name. Now, if I do an insert, let's say I have a movie, a new movie, and I want to insert it into my database, then it's not as simple as just to say I'm inserting into every table, because with our actors table, it could be that this movie has actors that already exist. So if an actor doesn't, if all the actors do not exist, then I also have to insert the actor information into the actor table. But at some point, once I have a lot more movies, then it's quite likely that a new movie points to existing actors. So then I have to just update this mapping table. So it sounds quite easy to just insert a movie, but in this schema design here, it actually means I may have to query my actor table before I can decide how to execute my insert. This is why I've put SQL magic here. Whereas in JSON, I can just do an insert on the collection and my entire data now is coming as these JSON key value pairs. So for those of you that are not too familiar with JSON, I basically have values that are associated with a key. So for example, the string value movie is associated with a key type or the quantity 1. So I have a self-describing data structure where all the information is inlined. So there is no need to query an actor table. The actor table here is, or the actor information is embedded in the JSON itself. And this is the key difference. You want to understand that this is in that relational world. I link information across different tables by the use of these column values that I use in joins, for example. So information is stored in a table and then I link from one table to the other. Whereas in JSON, I embed this information. So every movie where Danny DeVito plays in will have his name embedded in this actors array. Now, if it comes to the query side, let's say I want to find all the movies from Jonah Hill. I basically have, in the relational approach, I have to query these 4 different tables. I need to join them based on the columns, and then I pull all the information to build my business object or my Java object out of these 4 tables and different columns. So I basically have to reassemble my business object. In the case of my collection, I have a find operations which take like a filter or a query pattern or a query example. And here I'm just saying, well, I want to get all my documents which have a field actor and where the value is Jonah Hill. And we're going to look into these kind of queries a bit later in the lab itself. So if this doesn't make a lot of sense right now, that's fine. This is what the lab is for. Good. Now our application has been quite successful, but as with most applications, our initial assumptions were a bit incorrect. So we have to make an application change. So basically, we realized that a lot of people want to find a movie based on the year when it was released. So we want to add a property year release to our movies. And also what we didn't realize initially that there are books which can have more than one author. So our string author is now a list of authors. So this is a schema change. And now we want to look at the effect that it has on our database. So what it means is twofold. In the relational case, we have to add a year column to our movies table. This is still a pretty benign schema change. Probably all the existing movies will have a null value here, but a lot more problematic is this cardinality change, where now a book has not a single author, but instead can have multiple authors. So it's a similar situation as with the movies, a many-to-many relationship. So we need to get this mapping table in between. And now this means that all my existing rows need to be modified to basically pull out the author information and put it in this author table. I have to change all my insert. I have to change all my queries. So this is quite an invasive change. And it also means that my application change has to be synchronized with my database schema change. So this is something, I don't know, where you would work the weekend when there's low volume to just do it. So let's look at the JSON example. Well, JSON is schema-less or schema-flexible, meaning you can just insert a new record which has a new field. So from now on, all our movies have a new field released. We don't have to touch any old records. And I can immediately query my data based on this released field. Or in the case of the cardinality change, we're now inserting a book with multiple authors. So instead of author pointing at a scalar string value of a single author, it now points at an array of strings. And the nice part is that my query pattern doesn't even change. So if I look for author J.K. Rowling, it is actually now looking in, if this is an array, it's actually comparing J.K. Rowling with every item of the array. And if one of them matches, it will select this document. So this is to give you some motivation on what the differences are to use JSON instead of relational. And you may have the perception now that, okay, I will no longer do anything with tables. Everything is JSON now. And be warned, so the next slides will also tell you some benefits of the relational model. And then the workshop will cover how we can combine the best of both worlds. Just want to emphasize right now, please use the links to get your to get signed up for an Oracle Cloud account. Look at the workshop. The first steps describe how you provision an autonomous JSON database. You can pick a 19C or a 21C database for this lab. I will use 19C, but I will also explain later what the differences are between 19C and 21C. So please do this now while I continue speaking. So, okay, why wouldn't we only use JSON in the future, and why wouldn't I want to use a system that could only do JSON like some NoSQL databases? Well, one thing is, if we go back to this, when I talked about embedding versus linking, is that if you have more information on something that you embed, let's say for an actor, we no longer just want to store just the name, but we want to have some additional information, maybe the year when they were born or something extra. Then now all that needs to be repeated everywhere where you point to this actor, because the information is embedded. We're no longer linking to, or we're not linking to the information, we're embedding it. So now you have to, whenever you do an update, you have to change all occurrences, and you at least want to have a system that can do updates transactionally. Otherwise, you may have inconsistencies. So a lot of people who use NoSQL JSON databases may then have some problems if data gets embedded and becomes inconsistent. So this is something we really want to avoid. So that is one consequence of embedding. The other one is that if you really have different entities and you try to embed them, then this becomes quite user unfriendly or problematic to really operate with. So we were initially, I said, we are building something like an online shop. So in an online shop, you don't only have products, but you also have customers and orders. So here we have a bad example of an order. So we say there is an order, it has an order date, so far so good. It has a customer, but then here we have to embed all the information of that customer, and could be a lot more than I have here. And then this customer orders some product. So we have these line items array, but instead of just listing, let's say, the quantity and an ID of the movie, we now have to embed all the information of that movie or whatever they order, including all the actors in this example. So at the end, you're kind of taking this embedding business too far if you would do it this way. So there are examples like this being put out by NoSQL databases. So often they have limits with joins, so they can store things in separate collections or in separate units. So they kind of say, okay, because we're not really that good on joins, we kind of pre-join the data, and this is what you see. So embedding could also be called pre-joining, but at the end you have like a big mixture of unrelated things, really different entities, and this becomes quite problematic, not only large and repetitive, but if you wanted to do analytical queries over this, then this is quite complex. So what you want instead, even if you work with JSON, you want a system where you can store your entities separately. So you may have an entity purchase order or an entity customer. And even if you use this in, or even if you represent this in JSON format, you want to be able to perform joins or transactional changes across these different entities. And that is where using a relational database really shines, because that can, in the case of Oracle, we also support JSON, but we can do all these like very basic relational things like joins and transactions. Another thing where relational databases shine, or where this linking really shines, is that you can start your query at every table. JSON is a hierarchy, so there is like a just one way to start your query, and then you have to drill down. So let's say we had some query on actors. Now in the relational pattern, you could start directly with accessing your actors table. In JSON, you would have to drill down through the movies to the actors, so there is no direct access to actors. Or what we do in this example, it's looking a bit more complex, but it's just explaining how you would execute a analytical queries. Let's say you wanted to find out which products are very popular in a certain zip code. So then you would link your orders. You would get, let's say, the zip code or the region code from your customers. And then you would go back through the line items to the products and then to the movies, etc. And the nice part of this is that since you can access and join these tables, the optimizer typically picks a very good execution path. So if your use case is such that you also want to do some analytical queries, then you also want to have the ability to drive queries. And this is what the workshop shows, that we can bring our JSON data into the relational model, and then we can also do queries like this, analytical queries over JSON data. And with this, I already hinted it, it's not JSON or tables. It's really not a choice you have to make. You can get the best of both worlds, JSON schema flexibility, as well as joins, transactions, analytical queries, if you use a relational database with JSON support. And this is what we have with Autonomous JSON Database or Oracle Database in general, strong support for JSON data model without having to give up any relational core concepts. And with this, I want to share my browser here. I hope you can see my browser now. And this is the workshop. Let me just scroll back to the beginning. So this is the step I hope you completed by now, where you got your cloud account and you signed up and you created your autonomous JSON database. And now we're gonna look through the next step. Oh, by the way, on this getting started, now where was this? The provisioning, introduction, oh, here. Yeah, there is like a little video you can watch, and it's also explaining JSON in the introduction. So if you're not very familiar with JSON, now you could also read this part, and this gives you like a brief description of how JSON data looks like. And then let's go to working with JSON collections. And let me quickly log in. So I'm using my own always free tier cloud service here. So I'm using exactly what you have. I have nothing special here. So you see you're using a free tier account. Okay, nice, you get the same. And then I can click on Oracle databases. And we want to look at autonomous JSON database. And you saw already that there are different database choices. So there is also a autonomous transaction. So I can speak a little bit to that. So basically autonomous JSON database, autonomous transaction processing, and autonomous data warehouse, they all are using this more or less the same technology underneath. It's the Oracle database. Data warehouse is more for analytical queries. I see you can't use that with always free, but you could use autonomous JSON database or autonomous transaction processing in always free. There's not a big difference in the always free tier. So you could also, if you already have what we call ATP, autonomous transaction processing, you could do the lab on that as well. It's only if you upgrade to a paid tier, then autonomous JSON will be significantly cheaper. I think it's 25% of the cost. So you get like a huge discount. And why is that the case? Well, because autonomous JSON is limited for relational data. So as we're gonna see later, even if you have an autonomous JSON database, you can create regular tables. but the data inside would be limited to 20 gigabyte. And I emphasize it's only the non-JSON data. So if you just use a lot of JSON data, that's no problem in autonomous JSON or AJD. And you can also always upgrade an autonomous JSON database to an autonomous transaction processing. So it's full compatible with all of SQL and always upgradable. So you see with Always Free, you can have two databases. I have here an autonomous JSON 21C, and here I forget to give it a good name. This is a 19C database that I'm using here. Doesn't really matter for this lab if you signed up, if you use 21C or 19C, you can see it here. And I hope that if you want to follow this lab, you have a similar screen here where you see that AJD or ATP is available. And then you click on this Tools button here, and we're going to open the database actions. And this will give us to the user interfaces. So I'm logging in. This is this admin password that you had to provide. Let me make this a little bit bigger. And now what I do here is I right-click on it and open this in a separate browser. And this allows me to have both windows side by side. Otherwise, I constantly have to go back and go from one window to the other. So it's a lot easier to have to open these two tiles in separate windows. So what did I open here? I opened this JSON user interface. This is what gives me the ability to work with JSON collections. And I also opened the SQL interface, what we call SQL Developer Web, where I can run SQL queries. So now if we go to our JSON database here, there is a collection. I think this is the one that gets pre-created. So if you click on here, I think there is some sort of a, let me just drop this, okay, let's drop it. And what happens if I open it again? Then, yeah, see, this is what happens. There is like a wizard that explains you these different options. You could either click through it or just close it, because I will explain it to you. So now let's close this one. I only need one open. And the first thing we do is we create a new collection. So if there is no collection, you see this extra button. Otherwise, you could just also click here to create a new collection. There's a lot of complex stuff here, which you can all ignore. The only thing you want to type in here is the collection name, and we call the collection product. And by the way, all this is described here with a lot of screenshots in detail, how you do it, so you can go through this step by step. Good. Now we want to insert some data. And we want to insert these records, and you can always click here on copy, or you can just mark it and type Control-C, but copying is easier. Then I click on this button here to insert a new document. And this is just a user interface. So the purpose of this workshop is to work with JSON and to understand the concepts behind JSON and this API without having to install any extra software or to use a programming language. In a real application, you would obviously do all these operations that I'm about to show, like inserting data, querying data. You would do that from a programming language like Java, Python, JavaScript. And so this is really just to get an experience with Soda and JSON without having to install something. So let's insert. I think there is a bit more data that we're gonna insert. So this is a bit of copy and paste until we have a few documents. So we have a movie, another movie. There's Aliens. That's also a movie. Okay, and I think there was a fourth one. Okay, and this is actually a book. So it's here. Let's insert this book. So now I have 4 JSON documents in my products collection, and I see all of them here. So I can also, there's these symbols where I could delete it or replace it or update it. But for now, we want to look at the query aspect of it. And the query or the filter expression is in this window. And here we say this is just like an empty object, which means everything will be selected. But if we go to the next step, which is step 3, finding JSON documents in the collection, there is this query pattern, and I will explain this in a second. So it's basically ID colon 101. So the query is a JSON itself. We call it query by example, or QBE. This is the term you will find in our documentation. You could also think of it as a filter expression. So what does it do? We're matching this expression, this filter expression, with all the documents, and we want the documents that have an ID 100, or that have a field ID with a value 101. We want only those to be selected. So if I click here on this play button, you see the movie, the thing is selected because it has this ID 101. And again, so this is this query pattern, and you could issue the very same from your programming language. So here I'm just using, for ease of use, I'm using this JSON workshop user interface, but in your Java or Python Node.js program, you would still use such kind of query or filter expression. Good. Let's say we wanted to find out all the DVDs. It would be this format equals DVD. Then I guess we would select what's 2, what's the other? Was that a Blu-ray? I don't know, but we had 3 movies, 2 of them DVDs. Okay, so these were selected. Or if I wanted to, I can also negate this. I could say, find me everything where the type is not equals to movie. So since this expression has to be JSON itself, you won't find greater or smaller or not equal symbols, because they are not part of JSON syntax. And this is where you see these commands like $not equal. So dollar doesn't mean you have to pay money. JSON's been supported by Oracle as a free option forever. So it's just meaning this has a special meaning. And type $NE means I want to look where the type is not equals to movies, and we find our book here. And these things continue. So this workshop does not cover all QBEs. And because of time reasons, I will jump to the last one. You can look at our documentation to learn more about all these possible expressions. This is just an example that I can do multiple checks. So here I want to find out all the products with multiple conditions. So it starts with $and it's followed by an array which lists all the conditions that need to be true. And I want the price to be less than or equal than 5, and the type to be a movie. So I'm looking for bargain movies. And you see here, 2 movies are selected. This is just equals to 5. So if I change this to less than 5, I'd guess that it would no longer be selected, which is true. Good. So these are these QBE filter expressions. And now let's insert another document, which looks a little odd. So let's select our entire contents, our really large collection with 4 products. And I want to insert another product here, ID 100, fruit banana. This looks really odd, totally unrelated to everything else. But since JSON is schemaless, nothing is preventing us from inserting unrelated data, and especially inserting something with an ID that's already existing. So we have ID here for this movie Coming to America, and then we say, okay, another ID, which is a banana. That may lead to downstream problems if people want to look up products by ID. And here I'm using, nothing is telling JSON that ID has a special meaning. This is something from where I said, well, my application uses a field called ID, and I'd guess I want this to be unique. And probably if I have a lot more products, I will look them up often by ID. So I may want to have an index on this as well. So this is what we do. Now we can create an index, but before we create the index, I want this to be a unique index. So I'm deleting the banana. So I'm clicking here, goodbye banana. And I am now creating an index. And this is not only an index to quickly find my IDs, it's also an index that enforces uniqueness. So now I'm going to my other window, which is the SQL workshop. I'm now doing a SQL operations. And the main reason is not because I couldn't do it here, but we don't have user interface for this yet. So right now there's only support to create a search index in a soon to be released extensions, you will have a user interface to also create the index straight from here. But for now, we kind of go to the SQL side, and I'm creating an index. I call it product ID index. And what we're going to see later, that products, this collection is also a table. So I can use normal SQL like I do here to do operations on my collection/tables. And what I'm doing is I will extract a value from my JSON using a path expression. So JSON document, and we're going to see this. This is a bit jumping ahead. We're going to learn about JSON value and path expression in the future. But all you need to understand now is that I can pull up a value from my JSON data and use that to create an index. And I'm also saying I not only want to extract this value, I also want to convert it to a number. I want these IDs to be numeric values. And whenever there is an error in this conversion, I want that to be erased. So let's create this index. And index was created. And now we go back and we want to insert our banana again. Where's the banana? There's the banana. It will then say, nope, unable to add new JSON document. The unique constraint was violated just because that ID was already used. And while we're at it, let's add some more constraints. So let's say for our products, this is another example. This will also get rejected because the ID is not a number. I save that, or that you can experiment yourself. But now let's say we want to make sure that the JSON documents that we are inserting need to have at least a title and a string. The title needs to be a string, and it has to have a price, which is a number. So what I'm doing here, I'm using a relational construct called a check constraint. So this is an example of how I can combine relational constructs with JSON. And this is just one example. There's many things how you can combine relational concepts like partitioning, materialized views, etc. with JSON. But here we use the concept of a constraint to make sure all the JSON have the required fields. So I call this constraint required fields, and I want it to check this expression. I'm now scrolling to the right. What is the expression? This is the expression that I want to be evaluated for true before accepting an insert or an update. I want my documents to have a title of type string. So if it has a title, it's a number, or if it has no title at all, it will get rejected. And I want to have a price, which is a number, and it better be a number greater than 0, because if I have negative numbers, people pay less if they order more. So let's just run this check constraint here. And there it is. And now we go back to the workshop, and we're now trying to insert some things that are not valid. So here we want to add a movie Top Gun. So it has an ID, it's a number, and it's also not existing. So that part is fine. It has a title, which is a string. Okay. Insert, no. It's rejected because it had no price. So the required fields check constraint was violated, and I need to basically also provide a price. So let's add this to the document. So now I'm checking that the ID is unique and a number, title is there and a string, and price is greater than 0. All that is satisfied here, and that JSON document got created. Okay, so now we're going to look a bit at the REST part of it. So I've already said you don't need to install anything here, and that this interface, which we call SODA, it's kind of a document store API for your JSON data, and SODA stands for Simple Oracle Document Access. And you have support for that for Java, Node.js, Python, PL/SQL, like a bunch of different open source drivers are available. And there's also one available for REST. So what we do now is to look a bit at REST. And the simplest thing you could do is copy your URL up here. So everyone will have a different string here. And what you can do is you can just copy it in the browser. And let's say, this is also explained in the lab. Let's take a look at the lab. This was a bit, okay, exactly here. So there is this shape that we want to use, and the URL part is different. So, or you may not see it because I'm just not sharing that part of the screen, but I'm basically copying it into a separate window. Actually, maybe let me share this. So what I did here is I copied the URL from the web browser, and this part is specific. And we basically need to copy just this part out. So this is the piece you want to copy out from your URL. And I think this is your URL is this. So you want to copy this once out. And whenever there is an example in the lab, you just replace it with this. And let's see if this works. I'm now sharing my browser again, and I'm opening a new window, copying this here. And what I see now is a JSON, or the information about all the collections I'm having. So in this URL, let's explain a little bit. This is ORDS for Oracle REST Data Services. Admin was the username, so we did not create any separate user. We just used the admin user. SODA stands for Simple Oracle Document Access, and the latest is just there as like we want to call the latest API. And what I see back is the number of collections. Well, we have only one, which is products. And now if I add products to the end, what I see is the content of my collection. So in that browser, I was able to make a GET request to that collection, and I see the contents. So it is normally limited to, like by default, to like 100 or something. So I get pagination out of the box, and I get links to the next 100 or next 50, and I can choose if I want pagination or not. But this is very easy to have read access to the collection, but we want to do more. We want to insert data and query data, and for this, we can't use the web browser because that always just makes GET requests. So if you have a tool like Postman, you could also use this, but in this lab, we actually use curl to make requests in the Cloud Console. So how do you get to your Cloud Console? If you're going back to your window where you had AJD, there is this little window here, the Cloud Shell. And if you click on this, like a black box opens at the bottom, and it may take a while for the first time when you create it. So this could take a couple seconds. I think the second time you call it, it will be faster. And that gives you a console. So now I got my console here. I hope you do have the same. And I can do an ls. And let me just remove one file here. This is from this morning's event. So you see now there is, I can do ls, etc. And we want to use curl commands from here to make REST calls. And the first we're going to do, oh, this is one thing. Let's see if this goes through with me, but if you see, and you should be seeing a error message the first time you run it. So let's run this query here in curl. Where is it? Okay, so this is the stuff we want to run curl. I'm copying it now to my notepad here. I'm not sharing it, and I'm replacing this your URL with my personal database name. I'm coming back, and here I'm copying this curl command. I'm doing like a GET request similar to the browser, so we should be seeing the same result. I'm listing all the collections, and you see here that it lists my collection. If you do the same, you should be seeing a security error, something like not authorized. And the reason is that the security mechanism kicked in. We didn't authenticate this request, and it came from outside the database and outside of a web browser that was used to log in. So this uses ORDS as a mechanism, and ORDS, or Oracle REST Data Service, has a lot of different means to do with security and authenticate, and all of them are also supported in SODA REST. But in order to not have to explain all these concepts, we're just deleting this security checking. So you would run this statement in SQL Developer Web, like where we ran these check constraints, disable this privilege mapping, and then I can make REST calls from outside the database. So you would be a bit careful with this in production, and you would use proper authentication with username or OAuth, whatever there exists. But here, to keep it simple, we just disable that check. Good. I could run a query, the same QBE. I could say, for time reasons, I will skip this, but you can run a query with a filter expression here. What we're going to do is we're going to use an insert instead. So I want to insert a new document using REST. So again, I will copy this into my notepad and replace the variable your URL with my personal connect string, so to say, and I end up with a lengthy statement here. I'm not sure I can make the font size bigger in this window. Oh, I can actually, okay. So this is what it is. I'm doing a post request to that URL, and since it's a post on my products collection, it's actually an insert, and I say the data I want to insert, that's a new product, and it's actually a new product type. So in addition to movies and books, we're also now selling toys. So this shows the schema flexibility of JSON, well, if it would work. The mistake I made, there's like 2 HTTPS in my connect string, and let's remove one. And oh, again, this is a bit tricky with creating these connect strings. So I will give it one more try here. Yeah, so this will be something you may realize that if you have the slightest typo in your connect string or in the curl, I just had a new line when I had it in the editor, and that would make it stop working. So now you see it looks better. There is a response. It tells us that the ID, or that it was inserted. It got a hash if I wanted to use, or a hash value if I had a cache on top to invalidate it. Some last modified, some details that are not relevant for this workshop. Now, if I query it, you see that toy ET, the plastic figure, got inserted. Well, lucky me, it finally worked. Good, perfect. Okay, so this shows that REST access is possible, but what we want to do now is do a insertion, or like a bulk insert of more data. So what we do here is we're going to first download some JSON data from our object store. So let's just clean this up here. I'm doing an ls. There is no JSON file. And after I ran this curl command, you see that there is a file called test data. This is an array with movie data inside, and we want to iterate over this array and insert every movie as a separate object into our collection. So what I do here is also, again, a curl. It's a post. Now I'm pointing to my file, and I want to upload it. So let's see if I get this working faster. Copying it again into my editor here, getting your URL part replaced. And let's see. Yes, this looks good. So I basically get a big response back, which tells me different information for the items that were inserted. And now if I go back here to my interface, my JSON workshop, and I select everything with the empty filter, now I see that a lot more data has been inserted. So now you could use this. After this, you could play with this query expression, because querying just 4 different documents is less fun than querying a couple hundred. Okay. Yes, this concludes the REST part. So everything you can do in this console, you could do directly over REST, or Java or JavaScript. And we're now going from this document API, SODA, we're now going to the SQL part of things. And for this, we're going the SQL Developer Workshop. We already used that to create the index and the check constraint. And basically in this part, and one thing that I can show you, if I just refresh these tables, we will see that there is a products table. So we created a collection. Remember, in the JSON workshop, we created a collection, but under the cover, that led to the creation of a table. But I did not have to specify how this table looks like. Instead, it was a system-generated table. And I could describe it. I could say now describe products. And it will tell me, for example, these are these columns, and there is a column called JSON data type. It is of type blob. This is because I'm using a 19C database. We're going to take like a brief look at a 21C database in a second. Actually, I might already have it open here. No, not this one. No, I don't think I have it open. So let's just make this a bit smaller. And we go to the autonomous databases. This is my 21C. So some of you may have used a 21C database. So I can exit the Cloud Shell. So you see this is 21C. And I'm also going to the logging in. So this is now a different database, but I think I pre-populated it with the same data. So it will look quite similar. So I'm going to the SQL workshop. Now I'm getting confused with all these windows, but if I type describe products here, you will see that the data type in 21C uses JSON, because this is a new SQL data type we've added in release 21C. So we make use of this in the newer version, and in the 19C version, it's using a blob, but the data that's stored inside the blob is not textual JSON, but it's the same binary format that we store in a blob on 19C. So there are just very little implications of using 19C or 21C for this lab. Good, so let's then go back. This was the JSON workshop. Let me just move these things closer. Okay, so I can describe products. So now if I would say select star from products, I would see all these values that are there. There's also another ID column. This is the SODA ID. So there is it uses the same name as we use inside the JSON, and we're not making use of this ID. So you couldn't, for this lab, you can basically ignore that there is this ID column, but this is used for SODA to identify the objects. And JSON document here as a blob is not getting printed, but what I can do is I can convert it back into a string representation using JSON serialize operator and JSON document. And this will convert back this binary format into a string representation. So now you can read your JSON data again. Good. Now let's do a query using JSON serialize, and we are using we want to see all the documents, so we're going to do JSON serialize like in the previous query, but here we actually want to do it conditionally. We want the document to be a movie and the format to be a DVD, and we're looking for more expensive movies. So this is showing now here that you can look inside your JSON document column. So the way you look inside is here by just using dots, like in JavaScript, dot format, dot type, dot price, to look inside. And this is, again, as I mentioned, type sensitive. So if you would use an uppercase price here, it would not match. So in this, normally Oracle is not case sensitive, but the moment you look inside of JSON, we actually honor the case. And we not only honor it, you have to provide it in the right case. Let's just run this and we see how many dots. There's actually quite a few. So maybe let's increase the price. I don't know where the prices go. Maybe let's try 9. I don't think I had very expensive items in here. Oh, still, okay. What about 12? Oh, okay, so there's a big cutoff between 10 and 12, or what is it? Okay, so there's 2 movies that cost more than 11. Right, and you see these trailing functions, those I have not mentioned. So here, the easiest thing to explain it is for price. So we say we want to convert the price to a number before we compare it with this number, just to do the right ordering of numeric values. And on 19C, I could actually leave out the string trailing functions, because the default is to run or to return these values as a varchar. So if you just remove these string trailing functions, you will see that it does not have an effect on the query. But if we run the same query on our 21C database, we actually will get an error. And the error is an invalid comparison involving a JSON type value. And the reason is quite simple. So if you are extracting a value or a fragment from your JSON, then this is JSON itself. So you could extract nested arrays, nested object, but also scalar values from your JSON, like the type or the format. And by default, if you extract something from JSON, it is JSON itself. And to define how you want to compare it, you basically have to map it to a SQL domain or to a SQL type. And here we say we want to convert those to a string before we want to do the comparison. So it's always typed, because SQL is a typed language. So this is why in that lab, you will see that these trailing functions are present, makes these expressions a bit longer. It's required for 21C, not so much for 19C, but it's probably good practice to use that. Good. Then let's do, the moment we can query our data with, so let me now close. This was, I think, the 21C version. Let me just type here. I know I no longer need it. Let's just make sure. Yes, I can close this window. No more need to show 21C. And since I have access to my JSON data, and this is the same JSON data as I inserted in my JSON workshop, right? I have SODA access to it as well as SQL access to the very same data. If I make an update in one, it's immediately visible in the other. The data is not moved at all. It's the same data that we're querying. And since I have SQL access to my JSON data, I can very easily do some analytical queries. There's a bunch of examples in here. I'm not covering all of them just for time reasons, but let's say we wanted to find out the average, what is this, the year, the number, and we want to do, so this is the string, the year is a number. Okay, so here we are extracting just, this is not yet an analytical query, it's just extracting the values for year and title in the select list. So I don't have to select the entire JSON object. I can also use the same syntax in the select list, not only the word clause, but I can extract values here. And since I can do that, I can also use some calculations. So there is a field, decade, every movie is in a decade, like 70s, 80s, 90s. So I could just group my movies based on the decade and then calculate the average price per decade. And now you see here, movies from the 90s sell a bit better than movies from the 80s. Well, this data is randomly, the price data is randomly generated, so there's not really anything to read into here, but the message is, analytical queries over JSON are quite easy. So now the next step is, beyond extracting values from the data, there's also nested arrays in JSON. So you want to be able to look inside of your array. So I'm skipping the first query, we go straight to the second, and I explain the syntax. So if you want to look at values inside your JSON arrays, you may have typically more than one value. So if you expand them to the relational model or to SQL, it could generate you more than one row per JSON document. So let's say you only had one JSON document, but it had an array with 1,000 values, and you wanted to see these 1,000 values in SQL, well, you would generate separate values for those. And this is why we use this nested clause in the from clause. So here I'm using a query from my product. I use this nested clause to go to my documents. Then I'm listing all the columns that I want to project out. So I want to project out an ID, a title, a year, and I can optionally specify the data type. So for year, I can say, well, I want this as a number. If I don't specify a data type, it's just the varchar value. So here for ID, I might as well also call it a number. And then I can recursively apply the nested clause again. So this was nesting into my JSON document, so the first level. And this is the second level where I say, now I want to go to my array, which is called starring. So this is where all the main actors, the stars of the movie are in. And from that array, I want to project out a new column, which I call actor. So this array, let's take a look at this, how the JSON data looks like. So you see there is an array called starring, and this just has the name of these actors. It doesn't tell me that these are actors, it's just strings for each actor. And this is why here I give this value a column named actor, and I say the path expression. This is just what I'm selecting here now. So I could, if this was nested, so if I had an array of objects, I could like nest my way inside, like .name or .address, .zip, but here I want to select the entire string value. So if I run this query, I see the ID of the movie, the title, the year. So these are these first columns. And then I see for the same movie, all the actor names. So you see for this first movie, The Shawshank Redemption, you see it had 3 stars. So we see the names of these actors as separate rows. And all the values outside of this nested clause, the values are getting repeated because it's the same movie, therefore the same ID, therefore the same year. So what I did here is I brought the JSON data into a relational representation, and I didn't store it this way. It's just a view over the data. And I could actually create a view. I could say create view blah as this. Good. Okay, so now this is an example of just directly going to the array without the outer values. And now let's do one more query here. I'm always looking at the time. We may have to skip a thing or two. So now what I'm doing here is I'm nesting. I'm directly going to my JSON document, then the array of stars, project them out. Then instead of showing them all, I want to group them by actor, and I want to count how many actors there are. So if I run this, I see, for example, that Robert De Niro is actor in most of the movies we have, followed by Tom Hanks, Harrison Ford, etc. So I can now extract that information out of my JSON. So good. Okay, so now this was what we call this simple dot notation, because I am just using, I'm not using any specific JSON operators to access the JSON. Instead, I'm just using it in plain SQL. There is a second, a bit more verbose way to query the data, and it relies on what we call path expression and separate operators. So here I'm using the JSON value operator. I'm giving it the JSON document, and then I'm saying I want to evaluate this path expression $.format. And again, this is like very much like JavaScript. So I could add more dots, or I could add square brackets if I want to navigate inside an array. So this is really like a path traversal language for JSON. And then I can specify a specific return type. And I could also say what to do if a value was missing or not matching. So here I'm saying, well, I want to get the format, but if there is no value for format, this is what onEmpty means, like it's missing, then I want to return the value none. So if I run this query, I basically see just the DVDs, the Blu-rays, and then there is one value here. This one does not have a format. Maybe it's the book, I don't know, but that has the value none. So this is the essence of these operators. So this is an example of how I select multiple values, or yeah, so JSON value. Here you will actually see some hints that you are selecting multiple values. So there is JSON query. So JSON value basically returns you a scalar value from JSON. So in this case, the format that is one value. What if I wanted to extract a fragment of my data, for example, the array of actors? So this is not one value, this is a complex value like an array or an object. Then I would use JSON query for this. So the hint is basically JSON query returns you a JSON value returns you a SQL scalar. Good. Right, another example on filtering. An interesting one is JSON exists. So this is an operator I use in the where clause. We already used JSON exists in this check constraint where we wanted to make sure that all our objects have a title and a price greater 0. This is an example where I use JSON exists in a query. So I'm saying I want to filter all my documents which have a field starring or stars where the actors are in, and I want to compare each of these items with Jim Carrey. So this is returning me all the movies where Jim Carrey is playing. And the interesting thing actually is if I run a query here, let's say, that I didn't want to do. So if I write a query expression here, I could write staring equals this. This actually gets rewritten to a JSON exists expression. So the database itself only runs SQL operations like JSON exists, etc., meaning that if you provide such a simple expression, it gets automatically translated. So it's a convenience method. You don't have to write the SQL, that's done for you. And the benefit of this is the database just sees SQL expressions, so the optimizer can pick the best plan, like use an index or a materialized view, if you run these queries. Good. This is another example with a more complex query expression. And with this, let's look at JSON table. This is a bit similar to this nested clause. I think I'll pick this one. So this is, again, it's used in the from clause, quite simple to this nested clause. The nested clause is a syntactic shortcut for this whole JSON table operator. So you see it's used in the from clause. I pass in my JSON data. I'm selecting the entire document. Then you see this columns clause listed. So I'm saying I want the ID, a column called ID. And that's also being mapped to the JSON key name ID, and this is a number. Then I want to have a field or a column called product name. I want this to be a varchar 250. And the path where I want to extract this from the JSON is the title. So here I'm mapping the JSON field name title to the SQL column name product name. And this goes on like this. So these can be quite large. And at the end, you see something similar that we've seen with this nested clause, that you get a tabular view over your JSON data. So this is explained a lot more in length here. I recommend you do these steps, read the explanations to understand what's all possible. Yeah, one thing I could do now at this point, I could take such expression and I could just embed it in a view. So I could say, create view, movie view. Then there is movie view created. So I could just look here at my views and I would see the movie view and I see all the field names. So now I could do, I guess, like just a select star from movie view. And at this point, my data looks like if it was coming from a table. So let's say I had a tool or a query builder or some analytical machine learning, etc., that doesn't understand JSON. Well, all I do is I create a view and my data becomes accessible to relational tools or someone who doesn't want to query JSON directly but prefers to go over JSON. Good. Okay, so there is also methods to update your data. I will skip the first one and we go straight to JSON serialize, and we want to update product 515. So let's look in here what this is. ID 515. oh, this is the movie, The Terminator. Okay, we want to do an update here. What do we want to update? Well, I'm using JSON transform in the update part. So this is where in the where clause, where I limit this update just to this one movie. And I use JSON transform to make an update. And JSON transform can have one or multiple modifying operations. Here I use 3. So I'm first setting a new field duration to 108 minutes. This field was not existing. Then I make an update to the price. Arnold Schwarzenegger movies apparently sell better, so I increase it by 10%. And I append a new value to the array. And let's run this, update it. Now I can query it here. So look at genres, 2 values, and I look at it, and now you see an update has been made, immediately visible. There is the duration, and the price is increased by 10%, which gives us this odd number here. So I should have used the round on top of this. Good. I could also, let's do a little skip from querying JSON data into generating JSON data. And let's see if I still have that other table. Yes, I have a table emp. So let's do select star from emp. So there is no JSON in here at all. It's just, if I would explain it, there's an employee number, a name, and a salary. So no JSON at all. This could be like a table that was created a long time ago. And I want to convert that data into JSON. So all I do is I use a JSON generation function. Here it's JSON object. I could select the field names that I want to be part of the JSON object, but I'm using the star for every object to be there. So you see my rows have been converted to JSON objects. I could also generate one large object using an aggregate information. So JSON object will give me one object per input. JSON object ag will combine them into one single object. I'm using the employee name as the field name in the JSON and the corresponding value here, the salary divided by 1,000. So if I run this properly, I will get one object, and it says Sigourney 800, Tom 200, Arnold 500. So I can basically, there's also array and array ag as generation functions. So I have a lot of choices to convert my data into JSON. So this is an example for JSON array, array ag, etc. Good. Now there is an interesting use case. And again, because of time reasons, I'm considering skipping some parts of it. Yes, I will go to the result of this query, and I'll explain it once it's there. So it looks a bit longer. And let's go back to this example where we look at the JSON. So the way our JSON data looks like is that we have our movies as separate JSON objects, and each movie has a list or an array of actor names. And maybe we realize that a lot of people want to find a movie based on the actor. They're not looking for the title or anything else. They just say, hey, I want to find out all the movies by Arnold Schwarzenegger or whoever. So we want to inverse the mapping. So here we have a mapping from title to actor. But what we want to do is actually have a mapping from the actor back to the movie or to the title. So how do we do this? So it's quite easy in SQL. So what I do here is I use this nested clause to extract all my actors. So I've shown this before, and I use this in the with clause. So in a with clause, I can basically inline subquery. So I create a subquery that's called actor to title map. And this is just extracting the title of the movie, the ID, and the actor. So if I would run this, I would just see a long list of titles and actors. But the actors here could be duplicates. So what I do in addition is I have a second clause subquery, which I call distinct actors. And all it's doing is select distinct from this above query. So now I know all my distinct actors, and I have a mapping table back to the movies, and I can use this to generate a new JSON where I take my actor's name as a field name and a movie field, which points to all the movies they play in. So I create a JSON array. Maybe let's run this so you can see this already on this page here. So what I generated is, let's look here at Robert De Niro. So I used this object. This is Robert De Niro as the actor name, and movies points to a array. So this is what ArrayAct did, and I queried my actor's movie or my actor's title map to find out all the movies, and I put them in here. So now this is, I pivoted the data. Instead of having movies point to actors, I now have actors point to movies. And I could also create a view of this, expose this as REST. This is also explained in this workshop. There's another step here that I will skip also for time reasons. This is a data guide. This allows you to derive a schema and to automatically create views. This is quite interesting. A lot of people like this feature because it simplifies the querying relational data. So if you receive JSON data from someone else, you can run the data guide and automatically create a view. So it makes these parts a lot easier. So this concludes the walkthrough through the workshop. And I believe we have about 10 minutes left. And with this, I want to go back to my slides. Yeah. One little aspect of it's obviously, how does this cloud service perform? A lot of people consider NoSQL databases if they want to work with JSON or dedicated JSON products. And we can point to this third-party like benchmark. This was an industry benchmark, YCSB, and a company called Wikibon looked at it last year when we launched our autonomous JSON cloud service, and they found us to be faster than competing NoSQL products. So there's basically no penalty you pay for having joins, transactions, etc., versus going to a NoSQL database. And the main reason is that Oracle is just very good at parallel execution. So if you have a lot of clients hammering at the same database, then this is what Oracle has been really, really good for. Yeah, this is the summary of everything I've shown at the key message. So you have JSON in Oracle database. So this could be one of our autonomous cloud services, autonomous transaction processing, autonomous JSON, but this could also be your on-premise database. Everything I've shown you here could also be done on-premise. You would then just have to install either ORDS, Oracle REST Data Services, and or these drivers for your programming language. Like this is the list of languages we support at the moment. So if you have Java or Node.js, there are drivers, and I believe these are open source drivers that you can connect your program directly to make use of these SOTA operations. And at the same time, on the right side, there is all the power of SQL if you want to do reporting, analytical queries, machine learning, etc. This is another example here where it's really simplifying things to move it into the database. So this was a real customer use case. We were approached with a very large customer that stored their customer data in a relational database. And this was kind of a legacy system. So many tables, relational, all the customer data. They wanted to modernize some of their applications by adding REST microservices on top of it. So they started out with a dedicated NoSQL database product that supported JSON, and they wanted to use this as a read-only cache. So they wrote a Java program that read the data from the tables, converted it into JSON, put the JSON onto a messaging bus, which then populated the NoSQL database, and then they could read or a read-only cache of the same data there. But the problem were manifold. One was that a relational change could take up to 2 minutes before being visible in this cache. Others are just the amount of maintenance with Java programs, messaging bus, etc., point-in-time recovery, if you have multiple database, was also an aspect. So what they did at the end was to move this all to Oracle with JSON and just use SQL functions or the SQL JSON generation functions and views. So now they have a consistent data in the same database. Everything gets, if you do a point-in-time recovery or import-export, it's all the same database. And in addition, they can even serve this from the same REST services. So it's all served by ORDs. No need to have different databases and different REST services here. Yeah, like almost done here. Last slide for those of you that primarily work with on-premise. So what we've shown here in this workshop is the autonomous JSON or an autonomous database. As I said, it's all possible on-premise. So right now, our long-term release is 19C, and I guess a lot of you are, if you are using on-premise, are upgrading to 19C. There is also a 21C version coming quite soon. That's what we call an innovation release. It won't get supported so long, but here you get access to newer JSON features like JSON type, for example. So that's a reason why you could consider using an Oracle 21C. Yes, and this concludes this presentation, and I'm giving to Tara, who wants to speak a little bit about future events and a quiz.
Yes, thank you, Beta, for the great presentation. So if you guys enjoyed today's session, we'd like to invite you to join us on July 21st for our next lab in the series, where you'll learn how to utilize Oracle Database 21C's new feature that allows you to write server-side JavaScript in your Apex applications. And then we also encourage you to share with us any feedback that you'll have on today's session or what you'd like to see from us going forward. So next slide, please. And then in addition to the masterclass series, we'd also like to invite you to join us for the Developer Live event on simplifying modern application development, which will be held on August 3rd. And the event will include technical sessions, hands-on labs, demos, panels, and a live Q&A with experts. And you'll learn about building containerized web applications, using relational databases with modern apps, securing modern application workloads, automating deployment with and DevOps, and developing real-time event processing and analytics. So lastly, before we get into the remainder of our Q&A, we'd like for you to test your knowledge on what you learned today. So by completing several questions of our lab quiz correctly, you'll achieve a badge, which you can share on your social media.
Okay, I think we answered all questions and we are just in time, correct?
Yes, we are. Just wanted to remind everyone that the recording of the workshop will be available on the event page and then sent to you via email in the next couple of days. So with that, I'll go ahead and end today's session. Thank you again, everyone, for joining us here today, and we hope to see you again next time.